Okay, discharging a capacitor. I just want to go through the example that's on page 194 of the blue book. And in this one, we've got a circuit with 10 volts, and it's a circuit with a three-way switch, which can go to positions A, B, and C. And so we've got a charging up side of the circuit, which is this side, where when you connect to A, the current flows around and charges up the capacitor until it's charged, and the current will then stop. And then when you've charged up your capacitor and you've got your charge stored on it, you can use that as a source of energy, a source of charge to power this lamp. Now, back in the day before, this is how you have flash photography. So if you want a very bright one-off flash, you can't get huge currents for tiny times from a battery. Batteries aren't very good at that because of the chemistry of how a battery is made. So if you take huge currents out of a battery, you generally ruin the battery. So the way this works is, I'll just take you through the maths of how it works. Okay, let's look at the initial charging current. So let's say we've got the switch in position A. I've got 10 mega ohms and 10 volts. So current is voltage over resistance. 10 volts over 10 mega, so it's 10 times 10 to the 6. So I end up, my 10s cancel, and I end up with, so my two 10s cancel, I end up with 1 over 10 to the minus 6, which is 1 times 10 to the minus 1 over 10 to the 6, which is 1 times 10 to the minus 6, which is a small current. Now, what's the next step? How much charge can you actually store on this thing? So, going back to our standard capacitance equation, Q equals CV. So, C is 5 microfarads. So, I decided, for the sake of convenience here, to leave this as, to not bother with this, and say, I'll just give my answer in microcoulombs. So 5 times 10 is 50 microcoulombs, because that makes it, well, I just thought I did that for convenience. So with a maximum charging current of 1 microcoulomb, so I could have written that as with a maximum charging current of 1 microamp, it's going to take a long time to charge up to 50 microcoulombs. So this charging side of the circuit is going to take ages to charge. Charge. So it's going to take a tiny current out of this battery, and it's going to take ages to charge it. But that means the battery will be able to do this many, many times, because taking small currents does not really trouble batteries or cells. So I've put here, so with a maximum current of 1 microamp, it will take a long time to charge the capacitor. Okay, bear in mind, we're going to have the familiar charging graph, which means that that's the initial current. The current will be lower than that for a lot of the charging time, and this time is clearly going to be long. Okay, so that's what I'm just thinking. Okay then, now let's look at the discharge side of a circuit. So on the discharge side of a circuit, let's cover that up and say, okay, well, we're going to connect to C. We're going to connect there. We're going to connect across there. And now our circuit is just this side. So now this voltage across the capacitor will have got to 10 volts eventually if you waited for it to fully charge. Now, let's look at the numbers. The resistance in the circuit is now only 500 ohms. So I've now got I equals VC over R, because the voltage across the capacitor, which I want to call VC, is 10. 10 over 500, 0.02 amperes. Now, I've only got 5 microcoulombs on there. Now, 0.02 amperes implies that in 1 second, I'm going to get 0.02 coulombs flowing. Charge equals current times time. So in 1 second, the charge equals the current. So basically, so much current is flowing compared to that it's going to discharge in hardly any time. So we've got only 50 microcoulombs on the capacitor, but we've got 20 milliamps flowing. Okay, so we've got 20 milliamps flowing. So we've roughly got, I don't know, something like 20 milli divided by, if I did 20 times 10 to the minus 3 divided by 50 times 10 to the minus 6, you can see that I've got 2/5 essentially that, I could cancel that out and say, well, really, get rid of that. It's going to be 2 divided by 5,000, or 1 divided by 2,500. So basically, this current is enormous compared to the amount of charge we've got. It's 2,500 times greater than the amount of charge we've got. So basically, it's going to discharge in a tiny fraction of a second. In a few milliseconds, it's all going to be discharged. And that's how this works. Now you've got a large current, it discharges very quickly, and you can have a bright flash through your flash bulb. And then you'd hear a sort of weird, we used to hear a kind of weird whirring noise where the camera, having flashed, would flick back across to position A and slowly charge up the capacitor for the flash mechanism again. And then it will flash and then slowly charge up the capacitor. And that's how you could have a battery in your camera that would flash and flash and flash and flash many times, just creating that high pulse of current using a capacitor. Okay, so that's enough chanting for me. I think you really need to be able to get on and start doing some of the questions on page 196, 197 and working through different capacitor scenarios.